So hello guys, my name is Shivam Pandey and you are watching me on Discord and Encore YouTube channel. So the topic we are discovering and just letting you know is that hashing. So we are now going to cover the topic hashing today, and it is a very important concept in data structure series, and it is most frequently asked in your examinations also, and it is also asked in the gate exams. The concepts are very much easy, and if you just focus upon the basic steps, then you will get to know that what basically is hashing. So yeah, so now let us first see that what the definition of hashing says about. So hashing is a well-known technique to search any particular element among several elements. It minimizes the number of comparisons while performing the task. Unlike other searching techniques, hashing is extremely efficient. The time taken by to perform the search does not depend upon the total number of elements. It completes the search time with constant time complexity, which is big O of 1. Here it is clear that hashing is very much efficient technique, and the time taken by this technique to solve the like searching is big O of 1. Yeah, so it is very much efficient in terms of time complexity. So it takes a very constant and a fixed amount of time to complete the process or to execute the code. So now let us see that what basically is hashing and how to implement this hashing technique in our life. Yeah. So if we have an array data structure, which is called as has a hash table, so that is used to store the data items. Based on the hash key value, data items are inserted into the hash table. So I will tell you here that what basically is hashing. I will take one pen from here. Yeah, and thickness as this. Basically, if we consider a hash table, then we make an array like this. So we can have as many number of elements in the array. That number of elements would be decided from the question which you are solving. Correct? If your question says that you have to take the array elements as 9, then you have to take the number from 0 to 8, which gives you a count of 9. From 0 to 8, like 8 minus 0 plus 1, which gives you 9. And if the question says that you have to take 7 elements, then you have to take from 0 to 6. Always keep in mind that conventionally in Java, in a data structure, we take the counting from 0 only. We do not start from 1. The basic logic behind this is very easy, and it is not something that we have to start from 0 always. We can start from 1, but because in the conventional codes and the books and the notes you will get, there are always there has been always a thing that they use the starting as 0 only. So if you take an array like this, and you let's say the question says us that we have to divide that we have to make an array of 5 elements, correct? So we divide this array into 5 elements: one, two, three, 4, and 5. Yeah, so we'll make the first one as 0, 1, 2, 3, and 4. Correct? So we have 5 elements like 1, 2, 3, 4, and 5. Yeah. The example, the question says that the we have the key we have the hash function as a mod let's say mod 10, sorry, not mod 10, mod 4, and the key is 4. So if we have 4, and if the question has given us some values, let's say 12, 16, and 13, and 11. Okay, so these are the values which have been given to the question, and we have to arrange these values into the hash table, which we have to make by ourselves, and these values are given to us. So now let us take 12. And the question we have given the hash function as mod 4. So what we have to do is that we have to divide 12 by 4. So it is 12 and we're dividing it by 4. So we have to calculate our remainder when we are dividing the same. So we all know that 4 get divided by that 12 gets divided by 4 easily by 3 and remainder is 0 here. Yeah, so the remainder is 0 here. So now we look upon our array and we see that there is a place of 0 or the 0th array is the place where we have to place this 12. Now, why is it so? Because the values representing here are showing that these are the elements or the remainders which we will get from by dividing the value, and the remainder we will get, we have to show the values here. So we are getting a 0. So we have to show 12 here. Now if we divide 16, 16 get divided by 3 by 4 times. Yeah. So 16 by 4 is equals to 4 and the remainder is 0 here also. So now if we try to show 16 in place of the 0th value of this array, we see an issue that there is 12 also and there is 16 also, and we can't show two values on the same place. So this is the issue, and to solve this issue, we have created one hash table, and what we do is that on the zeroth place, we extend this array, and we do a thing like this. We make an arrow like this, and we extend the array, and we make a separate box to store the elements. And suppose that if we have 20 also, 24 or 20, 28 also, then we will store these values in the same format by extending this array. Yeah, so we are having 16 here. Yeah, for 13, for the element 13, we divide 13 by 4 and it gets divided uh, by 3 times and gives a remainder of 1. Yeah, so it will be stored at the first place, at the array element, which is having value of 1. So 13 will be stored here. And for 11, we divide 11 by 4, which gets divided by 2 and gives a remainder of 3. So we will store it by 3 here. So we will store it here. Yeah, so 13, 11 will be stored here. So the array will look like this, and these are the elements which we have taken in the question and have arranged it into a proper sequence of the array, considering the hash key and the hash table. Yeah, so that was the basic idea behind it, and I tried to explain you this concept. And now let us move ahead and see what else we can see in this concept. Yeah. So we have been given a hash key value. Yeah, so this is exactly the thing which I've explained you 2 minutes before. Hash key value is a special value that serves as an index for the data item. It indicates where the data item should be stored in the hash table. Hash key value is generated using a hash function. Yes, I've told you all these things that there would be a key, a hash function, and a hash value. So hash value are those values which you will be getting from the question, and you have to just make an array like 0, 1, 2, 3, 4, starting from 0 and up to the number which you have been given in the question. And for the hash function, you will always get the hash function in the question. You don't have to worry for that. And this is the easiest thing you will get in this unit. So hash function is the definition is given, and we have been explained here that what is hash function and when to use it. Types of hash functions are also given here. It has been mentioned here that there are various types of hash functions available, such as mid-square function, division hash function, folding hash function, etc. It depends on the user which hash function wants to use. So I will explain you all these types of hash functions one by one. Yeah, so now let us see what are the properties of hash function. The properties of a good hash function are that it is extremely computable, it minimizes the number of collisions, it distributes the keys uniformly over the table. Yeah, so you have seen that the example which I have taken before, it distributed the elements which were given in the question very evenly. It was not there that each element was stored at a particular place, but the elements were divided into the array very uniformly. Yeah, so this is the key idea before hashing, behind hashing, and for what we use it for. Yeah, so it is extremely computable. Yeah, it minimizes the number of collisions. Yeah, so it minimizes the number of collisions also. And if we get different remainders, then we can store it differently at different places, and which removes and which solve the problem of collisions also. So basically, there are ways to solve collisions also in hash function, which we will get further in this lecture only. We'll cover all the points. So yeah, collision and hashing. So we have got the heading as collision and hashing. Now let us see that what is the problem of collision. So by the example which I have taken, we saw that 12 and 16 have remainder 0 and they have to be stored at the index 0. But there is a problem that both the elements can't be stored in a single array. They have to be separated by something so that they can be stored in a array. You all know that an array element can only store one element, and if we want to store two or three elements, then it is not possible in array because each element can store only one element in an array. So to solve this problem, we have different techniques and different methods to solve this collision technique. Now let us see what is the collision resolution technique. So the collision resolution techniques are the techniques used for resolving or handling the collision. Right. So in the collision resolution techniques, we have two types of techniques. Yeah. So first one is the separate chaining, and second is the open chaining. So separate chaining is the open hashing technique also. It is also known as open hashing technique. And the second one is the open hashing, which is also known as the closed hashing technique. So closed hashing technique is also having three types of technique. The first one is the linear probing, quadratic probing, and the double hashing technique. So now let us start quickly with the separate chaining. So I've already explained you like how to make the hash function, hash table, and everything. So now let us skip this like theory part and let's move on to the question, right? So we have been given an example using the hash function key mod 7. Yeah, so we have been given the function key mod 7. Insert the following sequence of keys in the hash table. So we have been given this all the values. So we will do one thing. So now let us try to solve this question, right? So now let us make one array. Yeah, so this is the array which I'm going to take for this question, and I'm going to make seven divisions in it. One, two, three, four, sorry, four, five, six, and seven. Correct? And I'm numbering it as zero, one, two, three, four, five, six, and seven. Right? Yeah. So now let us take the number 50. Now we try to divide 50 by 7. So on dividing 50 by 7, we see that number gets divided by 7 times of 7 and the remainder is 1 here. Yeah, 1 is the remainder here, right? So we place 50 at the first place of this array. So we place 50 here. Now we take the number as 700. 700, right? And we divide it by 7. So this gives us 700 gets divided by 7 by 100 times and it gives a remainder of 0. So 0 comes here and it will be stored at the this place at the 0th place because the remainder is 0 here. If we have 76, if we have 76, then dividing it by 7 would give us a remainder of 6. So it would be stored at the sixth place. Now let us take 85. 85, okay. So 85, when we divide it by 7, then it would give a remainder of 1 and it would be divided by 12 times of 7. So 1 is there. Now the problem comes into the scene. The problem here is that at the ones place or at the key one, there is already an element 50, and if we are already and if we are again getting an element to be stored at the first place, then we don't have the space for it. So now we have to do one thing, that we have to make one array like this, a separate array, and we have to store 85 here. So this solves the problem of collision, and by this thing is solved. And I'm not taking all the other elements as well because it is very much easy, and you have to just divide the element by the hash function, and you have to just place it on the table. And if there is a any situation of collision, then you do one thing: you extend the array, and you like the concept, we create the linked list. Simply you have to do one thing here, and you have to make one linked list type of thing, and you have to show the element in that in that list. Yeah. So that was the key idea behind the separate chaining type of collision handling technique. And yeah, so similarly, you can see in the solved example, 50 showed at the ones place, 700, then you can see 76, then you can see, yeah, so if we get the 85, then it is stored like this. You can also read from here. The next key to in the table is 85. A bucket of hash table which needs to be 85, so Sun Morton is 1. And since bucket 1 is already occupied, so collision occurs. Separate chaining handles the collision by creating a linked list to bucket 1. So key 85 will be inserted in the bucket 1 of the hash table. Yeah. So that's the idea which I was explaining to you. Yeah, so you can also see the other elements as well. On 92, if we divide by 7, luckily gives us 1. Not luckily, but for just calculating it and to get more of it, we get and again an element which gives a remainder of 1, and we can store it here as well. Yeah, like this, like the same thing I was telling you. On the step 7, we got 101, and 101 gives a remainder of 3. So it would give a remainder of 3, and we can store it at the third bucket by creating a linked list at the third bucket. So now let us see what is open addressing. In open addressing, unlike separate chaining, all the keys are stored inside the hash table. No keys stored outside the hash table. Technique used for open addressing are linear probing, quadratic probing, double hashing. So yeah, so open addressing is a technique. In the previous technique we have seen that we are creating a linked list and we are storing the elements outside the hash function. Yeah, if you see here, then the hash function is this much only, and we are moving out of it, and we are then storing some elements. So this is good, but it is not very much practical, and it is not very much it then basically it is not very much good to be considered. Yeah, because we are facing an issue that we have to again create an linked list, and we have to store the elements like that. So if we try to code it also, then it would be a little much difficult for us to like code it and to implement it. So we have got an technique of open addressing, and there are three techniques under it. So now let us see these techniques one by one. So operations and open addressing is that insert operation. Yeah, so the same things are there. So I'm not going to tell you these things again, and I'm just skipping these things, and we are moving to linear probing. So in linear probing, when collision occurs, we linearly probe for the next bucket. We keep probing until an empty bucket is found. So yeah, I will try to explain you these 2 points before. Yeah. So the first point written over here is that when collision occurs, we linearly probe for the next vector. This simply means that, for example, in the previous question which I have taken, the key mod 4.1, the problem there was that if we get two elements as 12 and 16 and both give the remainder of 0, then collision happens there, and we do not have any like fixed way to solve it. So here we can solve it by a separate or a unit technique. where we do not have to place the element outside of the array, but we can store it inside of the hash table, and we do not have to make a separate linked list for it. Yeah, so for doing it, you do one thing. Now let us come to a question to like tell you more about it. Yeah, for linear programming, we have given a function fi equal to I. So this would be always given in the question, so you do not worry for it. And it is very much easy, and I will let you explain this concept very easily. And you can also see the code of this linear programming. This code is easy, and I'm not going to explain you the code here because this lecture is not made for code. I'm going to explain only the concept, the theoretical concept of hash table. And if you want, I can make another video for the codes as well, and I would cover all the codes of this whole chapter, which is unit third, which is trees. Yeah. So now let us see the example of linear programming. Yeah, so it is a very good example, and it is often seen in the exams that that such type of questions are given into your exams. Correct. Here we have been given some elements. I think the question is not complete because question is not given. I think so that it is the very similar question that we solved in the previous one. No, 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 it is not the same. So no problem. Yeah, so I can tell you from the question itself, from the answer itself, that what can be the question for this. We have been given elements as 76, 93, 40, 47, 10, and 55, and we have been given a function of key mod 7, which is key is 76, for example, and if we divide by 7, then we get a remainder, and we have to place it in the this this box. Yeah, correct. So now let us see that how we can insert this element. For example, if we get 76, then 76 by 6 gives the remainder of 6, and we can store other 6 bucket, and we do not have any problem here. So we move ahead before so we can move ahead, and we can insert 93. Oh yeah, so 93 gives a remainder of 2, and we can store other second bucket without any problem, and we move ahead. Right. 40. So 40 by 7 gives a remainder of 5, and we can store as a fifth place without any issue. So it works fine here. Let's move ahead. 47 by 7 gives a remainder of 5. Yeah. So here the problems comes in. So here the problem is that 40 by 7, 47 by 7 gives a remainder of 50. Sorry, 5. And at the element 5, we have already an element 40. So what we would be doing now? Because the thing is that uh, we cannot store it outside of the array as well, and we have to keep it inside the hash table as well. So we do one thing that we increase the key value by plus one. Now you would be thinking that what is this plus one and where we have to do this plus one. So basically, you have to do one thing. That 47 by 7 is equal to 5. So the remainder is 5. But this place is not empty. So you have to find an empty place for this 47 so that you can store it. So you do one thing. You just see the element or the place where there is no element present in the hash function. Now let me explain you more clearly what I mean. I mean that if you look on at the fifth bucket, there is 40 stored here. Then you can't show the element here. So you skip this first element and you go on to the sixth element, sixth bucket. So here also you can see that there is an element 76, and you cannot store your element here also because there is already existing an element here. So you try to move ahead, and you go on to the zeroth place. And if you move here, you see that there is no element present at the zeroth place, at the zeroth bucket. So you see that there is no element. and you place your element into the zeroth index of the hash table. Yeah, so you have placed it. So we have what we have done is that we have been linearly just probing out, and we have been linearly searching for a place where there is no element present in the hash function, and we are just placing our element onto that place if we are having any collision, right? So you can see down here that there have been mentioned some values of probes. So probes is a new concept, and probes is nothing but the steps to find out the vacant place in the hash function. Now let me explain the probes with an example of 47 only. So yeah, 47, we have seen that the bucket we firstly found was 40. So 40 was not free. So we moved on to 76 and then to 40. So the first probe to find out the place for 47 was the fifth element, which is the first probe for this 47 element. So the first probe was for the place of fifth, but it was not free at that time. So we moved on to 76. So we took the second probe here, and then also we found that this place is also not free. Then we move on to the zeroth place of the hash function, and then we got the place which was vacant, and we showed the value here. So we got the third probe as here. So in total, we have taken three probes, one, two, and three, to store the element 47 into the hash function, into the hash table. Sorry, I'm again I'm using the words hash function and hash table very differently at different times. I'm really sorry for that. And by this table, I only mean the hash function table, and I don't mean hash value. Hash value is the value which is written over here and not by this table. Okay, so please make sure of it. Yeah, so if we divide to, and if we try to show the element 10, we get the 3, and there is not a issue here. We can store it here at the place of the third bucket. Now, if we try to show 55, then we see that the remainder of 55 is 6. So 6 also we can see that there is an element beforehand, and we cannot store here. So we the get the first probe here. Then you want to zeroth element, and we see that there is an element here also. So we cannot store it, and we get onto the first element, first bucket. So it is empty, and we can store 55 here. So we get a third probe to store it here. Yeah, so this was the question, and it is quite easy, and it is there is not much to explain in this, and you can easily solve it, and you can easily do it by practicing two or three questions on every type of hashing. You can do it, or I would say that you take one question only, and you try to solve it by every hashing technique that you have. Yeah. So the second one is the quadratic probing. Probing. So when collision occurs, we probe for the I squared element bucket in the ith operation. Yeah, we keep probing until an empty bucket is found. So yeah, the concept is similar to what I've explained to you in the previous video, in the previous slide. But the only difference is that we are that we are using the square of the key value. So now what does it mean, right? So for example, if we have the hash function as h of k, so we are using it as a hash function. So for showing, we use hk plus I mod 7. Hk was like which is a function hk plus I. So I is the thing which we have to take linearly as 1, 2, 3, 4, and if, for example, if the I element is taken as 1 and 1 is not free, correct? So we will not take 2 here. No, sorry, we will take 2 here, but I would be in square here. So if we take 2, it becomes 4. So hk plus 2 ka square becomes hk plus 4 by mod 7. Yeah, so this would give a different value. In the previous one, we were taking as I only, and it was giving us a different value. So here we use the square of the eye. So now you might be thinking that why is it so that we are using a square? So the problem in the linear thing was that we have to find that we have to uh, look out for every subsequent or every consecutive element in the hash function to find out the suitable place for the element to be stored. The good thing is quadratic probing is that it minimizes the probing and it takes the minimum number or lesser number of steps to find out the vacant place than compared to the linear probing. For example, if we have 10 elements or 50 elements and the key function is of key mod 100, then it will be more easier for you to store this type of elements in the quadratic probing than in the linear probing, right? So example we have been given here like this 76, 40, 48, 5 and 55. If you divide it by 7 then you get 6. So it is put at the 6 bucket. 40 by 7 is 5 and you can store it as a fifth place. 48 by 7 is 6 and you see here now here the problem comes. So 26 is not the sixth element is not free and we cannot store the value here. So you do one thing that you place this value. You can do hk plus I here. So firstly we use the hk as this function 48 and we do plus 1 it and we do plus 1 in it. So 48 plus 1 is 48 plus 1 is 49 and if we do the square then it becomes 49 and 49 by 7 gives you an value of 0 and yeah so the 0th place is free and you can store it here, correct? So it is the value the buckets we can store 48 in it. Now we have to insert 5. It is very easy and it is the place also free. So you can insert 5 at the second bucket and for 55 yeah for 55 we have an issue, yeah, right? 55 is oh, sorry. For inserting 5 the fifth place was not free, so we did one thing, we used plus 1. 5 plus 1 6. 6 is also not free, so yeah, it is also not free. Now we did plus 2, which is 2 ka square. So 5 plus 4 is 9, and 9 by 7 is 2. Yeah, so we stored 5 at the second element, and it took around 3 probes, like 1 for 5, 2 for 76, sorry, 6 place, and the third for this second place, the second bucket. So it took around 3 probes to solve this. And similarly, it goes on for 55 also. And I don't think that I need to explain it again and again. And we move on to the last and the most important technique of the this open hashing and the closed hashing is double hashing. So you can frequently see this question coming into your exams. The double hashing technique of the collision resolution techniques. So double hashing is that you get a function of fi equal to I into hash function of x. Now what is this? Correct. You might be thinking, what is this? So you can see from the function that hk h1k plus 1 dot h2x mod size. Here in the questions of double hashing, you will be getting two hash functions, like hash function 1 as hash function 2. And you have to take care of both the hash functions to solve this question. Yeah, so we take the example here, and by example, it would be more clear and more easier for you to understand. Yeah. So we have been given some values here 26, 93, 40, 47, 10, and 55. So 76 by 7 is equal to 6. It is not an issue. 93 by 7 is 2. It is not an issue. 40 by 7 is 5. It is not an issue. because 40 because the fifth element the fifth bucket is also free, and we can store the value here. Now the problem comes here. We get 47 by 7 equal to 5. And as the fifth element we have 40 here. So we cannot store it here. Alright, so we do one thing that we do 5 minus 47 by 5. Yeah, so this will be again, I guess 5 is the remainder here. So we have calculated it here. 47 by 5 again will give us. Yeah, okay, sorry. In the question, we have not been, the question is not written over here, but by like seeing this thing, I can imagine and I can say one thing, that the H2 function which have been given is that we have to divide the function by 5. In the H1 function, we were dividing the element by 7, and in the H2 function, we have to divide it by 7. Sorry, 5. So what we do here is that we have to calculate the first element, and we subtract the H2 function from the H1 function. So H1 function gave us the value of 5, and by H2 function we can calculate the value of this. So 47 by 7 will give us the value of 2, and we do a calculation of 5 minus 3, which would give us the value of 3. So yeah, so we have to show the element at the third place. Now let us see that the third element is free or not. So we see here the third element is free, and we got it in the first row. So we will store the element into the this place, which is 47. Correct? So that was it, and you can see the difference between separate chaining and open addressing. Basically, I'm not explaining you this difference. You can easily check out this difference from my notes, which I will be providing you very soon. And comparison of open addressing techniques have been given here. We can see linear probing, protective probing, double hashing. There have been different parameters on which they have been compared. The primary clustering, secondary clustering, number of probes, and cache performance. So yeah, that was all for this lecture, and we will again see you once again tomorrow. That's all. Thank you.